Alright, let's go. Number 10. Vimana. Ancient texts describe flying machines, thousands of years old, long before modern engineering, long before aviation, yet the descriptions sound mechanical, structured, engineered, not mythical, detailed, too detailed. The Vimana appears in Sanskrit epics, the Mahabharata, the Ramayana, vehicles capable of flight, capable of maneuvering, capable of war, capable of reaching the heavens. Some texts describe multiple propulsion methods, Mercury vortex engines, rotating chambers, directional thrust control, concepts that resemble modern aerospace diagrams, suspiciously familiar. The descriptions include lift, acceleration, vertical takeoff, navigation across vast distances. Some passages describe weapons of immense power, blinding light, shock waves, heat intense enough to scorch landscapes. Interpretations vary: symbolic language, religious metaphor, lost imagination, or something else. Because the strange part is not that ancient cultures imagined flying. Many did. The strange part is specificity, mechanical specificity, descriptions of materials, descriptions of cockpit layout, descriptions of energy systems, technical narrative structure, not poetic abstraction, engineering logic. Even 19th century scholars noticed. The tone felt different, less myth, more manual. Some later texts even describe pilot training procedures, navigation rules, flight safety, operational guidelines. Unexpected, unusual, difficult to categorize. Mainstream historians view the Vimana as symbolic, mythological, philosophical, expressions of spiritual ascent, not literal machines. But alternative interpretations persist. What if these stories preserve distorted memories, fragments of misunderstood technology, stories retold across generations, each retelling slightly less precise, until machines become myths, and myths become legends? Because human memory preserves patterns, even when meaning fades, even when context disappears. Sometimes, only structure remains, and structure can outlive understanding. The unsettling possibility is simple. What if ancient people did not fully understand what they saw? What if the witnesses lacked vocabulary? What if advanced technology appeared indistinguishable from divine power? Because from a pre-industrial perspective, any sufficiently advanced machine is indistinguishable from magic. Arthur C. Clarke's third law, still relevant, still unsettling, especially when old texts begin to sound modern. Perhaps coincidence, perhaps imagination, perhaps translation artifacts, or perhaps a reminder that technological timelines assume continuity, but history contains gaps. Gaps hide things: lost knowledge, destroyed libraries, collapsed civilizations, erased discoveries. We assume technological progress is linear. It isn't. Knowledge can vanish. Entire disciplines can disappear, reinvented centuries later. The question is not whether Vimanas existed. The question is whether technological ideas can appear long before their time. Because if even one description reflects real engineering, then technological history may not be as simple as we think. And this is only the beginning, because the next artifact was not described in mythology. It was physically discovered, and it generates electricity 2,000 years ago. Number 9. Baghdad Battery. Discovered in 1936, near Baghdad, buried in ancient soil, quiet, ordinary looking. A clay jar, a copper cylinder, an iron rod. Simple components, but together they form something unexpected. A battery, possibly, dating back over 2,000 years, long before modern electricity, long before Volta, long before circuits. The jar contains an acidic residue, wine vinegar, lemon juice, electrolyte, enough to generate voltage. Small voltage, but measurable. Modern reconstructions produce around 1 volt, enough for electroplating, enough for chemical experiments, enough for controlled reactions. The design is functional, minimal, intentional, purposeful, not decorative, not symbolic, engineered. The copper tube isolates the iron rod, preventing direct contact, allowing electron flow. Electrochemical potential, primitive yet real. The question is obvious. Why build a battery without a known electrical culture? No wires were discovered nearby, no devices clearly designed for electricity, no ancient light bulbs, no motors, no circuits, nothing obvious, which makes the mystery deeper. Some researchers propose electroplating, gold layering on jewelry, thin metallic coatings, techniques difficult to explain otherwise. Others argue ritual purposes, symbolic objects, coincidental chemistry, not intentional electricity. Debate continues, but experimental archaeologists replicated the design. It works, consistently, predictably. Repeatable voltage output, meaning the principle was viable, even if the purpose remains uncertain. Because technological knowledge does not always scale immediately, early discoveries can remain isolated, underutilized, misunderstood, or lost. Greek fire disappeared, Roman concrete vanished, Damascus steel became irreproducible. Knowledge fragments survive, without context, without explanation. If ancient engineers discovered electrochemistry, even accidentally, what else might have been discovered and forgotten? Because technology does not always progress forward. Sometimes it resets. Sometimes entire civilizations forget things, relearn them centuries later, thinking the discovery is new. The Baghdad battery forces an uncomfortable question. How many discoveries were made long before recorded science? And how many ideas vanished before they could transform civilization? If electricity was known, even in primitive form, then technological curiosity existed earlier than expected, much earlier, which means experimentation was happening, observation was happening, hypothesis was happening, long before the scientific method was formalized, meaning curiosity is older than science, much older. But curiosity alone is not enough. It requires precision, calculation, measurement, which brings us to the next device, a machine so advanced it should not exist in antiquity, a mechanical computer from ancient Greece. Number 8. Antikythera mechanism, recovered from a shipwreck, 1901, off the coast of Greece. At first, it looked like corroded debris, fragments of bronze, stone-like, unremarkable. Then, gears appeared, dozens of them, precision cut, interlocking teeth, miniature mechanical complexity, impossible for its time. The Antikythera mechanism dates to around 100 BCE, more than 2,000 years ago, yet its function is unmistakable. It predicts celestial motion, sun cycles, moon phases, planetary alignments, eclipses, even Olympic calendars, a mechanical model of the cosmos, analog computation. Gear ratios encode astronomical periods. One gear rotates, another responds. Mathematics embedded in metal. Hidden mathematics. Forgotten mathematics. The gear precision is astonishing. Teeth spacing extremely consistent. Engineering tolerance incredibly tight. Comparable to 18th century clockwork, but discovered in the ancient world. No known predecessor. No gradual evolution. No earlier prototypes. It appears fully formed. Technological discontinuity. Because machines like this require layered knowledge, metallurgy, geometry, astronomy, long-term observation, predictive modeling, transmission mechanics, system integration, multiple disciplines converging, unexpectedly early. Scholars once believed such complexity emerged in medieval Europe, not classical Greece, not ancient shipwrecks, not buried underwater for 2 millennia. Yet CT scans revealed hidden inscriptions, operational instructions, calibration markings, a user interface, designed for human interaction, designed for interpretation, designed to predict the future sky. Portable cosmology, a universe in a box. The mechanism encodes cycles spanning decades, even centuries, meaning its creators understood long-term periodicity, patterns in celestial motion, predictability in chaos. Predictability implies measurement. Measurement implies instrumentation. Instrumentation implies infrastructure, which implies a broader technological environment. Tools that did not survive, workshops that vanished, traditions erased. Because complex devices rarely exist in isolation, they emerge from ecosystems of knowledge, communities of engineers, transmission of expertise. Yet we find only fragments, a single survivor, like discovering a smartphone in medieval ruins, without manuals, without chargers, without context. The Antikythera mechanism suggests technological sophistication can appear, then disappear. History is not always cumulative. Sometimes knowledge peaks, then collapses, leaving only artifacts. Artifacts that look out of place. If one ancient civilization could build a mechanical computer, what other ideas might have existed, unrecorded, unpreserved, unimagined? Because predicting the sky is powerful. It gives control over time, over calendars, over navigation, over ritual. But the next phenomenon is not a device, it is a message, etched across a desert, so large it can only be seen from above. Number 7. Nazca lines. Across the Peruvian desert, lines stretch for kilometers, perfectly straight, unbroken, precise, visible only from the sky. The Nazca lines cover over 450 square kilometers, hundreds of geometric shapes, animals, humanoids, spirals, trapezoids, lines extending beyond the horizon. Some figures measure over 300 meters, longer than skyscrapers are tall, yet they cannot be fully seen from the ground. Their scale exceeds human perspective, meaning their creators designed images they could not easily observe, design without direct feedback, planning without aerial visibility, a paradox, because accurate large-scale geometry requires reference, alignment, measurement, surveying techniques. The lines maintain consistent width, often within a few centimeters, over vast distances. Some run perfectly straight for kilometers, ignoring terrain irregularities, crossing hills without deviation, maintaining direction with uncanny precision. Even modern survey teams struggle to maintain this level of consistency without advanced tools. Yet the Nazca culture had no balloons, no aircraft, no satellites, no drones. Still, the geometry holds. Researchers propose simple methods: wooden stakes, ropes, grid systems, incremental scaling, human patience, human ingenuity, possible but demanding, extremely demanding, because errors compound quickly at large scale. Small deviations become large distortions, yet the figures remain recognizable, proportionally stable, even after 1,500 years. Some shapes suggest astronomical alignment, solstice positions, star risings, seasonal markers. Others may map water sources underground, guiding survival in an arid environment, meaning the lines could function as both art and infrastructure, symbolic engineering, landscape as information, landscape as communication. But communication to whom? Pilgrims? Deities? Observers from above? Because the perspective problem remains unsettling. Why create images intended for aerial observation without aerial capability? Perhaps the creators did not need to see the full design. Perhaps meaning was local, segmented, each group responsible for one section, the full image emerging collectively, without any individual seeing the whole. A distributed construction system, collective intelligence, collective authorship. Or perhaps the intended viewer was not human. The shapes are unmistakable from altitude, bird altitude, mountain altitude, or something higher. The Nazca lines demonstrate something profound. Technology is not only machines. Technology is organization, measurement, coordination, shared intention across generations, a system capable of executing a plan larger than any individual perspective, because scale itself can be a form of technology, a way to encode information into geography, to communicate across time, to create messages that survive centuries, messages large enough to resist forgetting. But some ancient constructions go even further. They challenge not only perspective, but manufacturing capability itself. Stone shaped with impossible precision, angles too perfect, cuts too clean, assembly too exact, as if carved by tools we do not fully understand. Number 6. Puma Punku megaliths. High in the Bolivian Andes, over 3,800 meters above sea level, thin air, harsh climate, remote terrain, there lies a shattered complex of stone, massive blocks, scattered like broken machinery. The Puma Punku site dates to around 500 to 1000 CE, part of the Tiwanaku civilization, yet its construction raises unsettling questions. Some stones weigh over 130 tons, transported without wheels, without steel tools, without written engineering records. Even more unusual is the precision. Certain blocks exhibit near-perfect right angles, surface flatness comparable to modern machining, interlocking geometries, complex grooves, H-shaped stones repeating with remarkable consistency, almost modular, almost industrial. The joints between stones are extremely tight. So tight, a razor blade cannot fit between some seams. Some drill holes are remarkably straight, uniform diameter, smooth interior surfaces, suggesting rotational cutting, suggesting advanced tooling. But mainstream archaeology explains this differently. Stone hammers, abrasion techniques, sand grinding, copper tools, time, a lot of time. Years of incremental shaping, extreme patience, human persistence. Possible, but extraordinary. Because the stone material is andesite, extremely hard, difficult to shape precisely, even with modern equipment. Yet the geometry remains consistent across multiple blocks, suggesting measurement systems, templates, standards, quality control, processes, repeatability, engineering culture. Some stones feature recessed channels, complex internal angles, precise alignment slots, designed to lock pieces together, earthquake-resistant construction, shock distribution architecture. The site sits in a seismically active region, meaning structural stability mattered, meaning structural foresight existed. But the deeper mystery lies in transportation. The quarry for some stones lies over 10 kilometers away, across uneven terrain, uphill in places, at altitude, without draft animals capable of moving such mass efficiently, without known cranes, without metal reinforcement systems. Yet the stones arrived, positioned with accuracy, aligned with intention, which suggests organizational complexity, labor coordination, logistical planning, multi-year construction programs, shared knowledge transfer. Because precision architecture requires continuity, generational skill retention, systems thinking. But Puma Punku today appears incomplete, as if construction suddenly stopped, or knowledge suddenly vanished. The site looks less like erosion and more like interruption, as if a technological trajectory was cut short, leaving fragments of ambition, fragments of capability, fragments of understanding. The unsettling idea is not that ancient people had advanced tools. The unsettling idea is that advanced techniques can emerge without leaving obvious intermediate steps, sudden peaks in capability, followed by disappearance, technological islands in time. Because innovation is not always gradual. Sometimes it appears abruptly, driven by unknown catalysts, lost through unknown collapses. Which raises a deeper question. How many ancient engineering traditions were interrupted? How many techniques were rediscovered centuries later, believed to be modern, but actually ancient? Because the next structure pushes scale even further. Geometry so precise, its proportions still fascinate physicists. A monument aligned with cosmic measurements. A structure embedded in cultural memory worldwide. Perhaps the most famous ancient construction on Earth, and still not fully understood. Number 5. The Great Pyramid of Giza. Rising from the Egyptian plateau, massive, silent, unmoved for 4,500 years. The Great Pyramid of Giza remains one of the most studied structures on Earth, yet it continues to provoke questions. Approximately 2.3 million stone blocks, each weighing between 2 and 15 tons. Some internal blocks exceed 70 tons. Positioned with extraordinary accuracy, the base is almost perfectly level, deviation less than 2 centimeters. Across 230 meters of length, its sides align with true north. Error less than 0.05 degrees, more precise than many modern buildings. Constructed long before compasses, long before GPS, long before modern surveying instruments. Even more curious, its proportions appear mathematically significant. The ratio of perimeter to height approximates 2 pi, suggesting geometric awareness, or coincidence. The internal chambers are arranged along specific axes. Narrow shafts point toward ancient star positions, possibly Orion, possibly Sirius. Celestial alignment embedded in stone. Stone used as information. Stone used as mathematics. Stone used as memory. The internal granite blocks show machining marks, straight cuts, flat surfaces, tight joints. Granite is extremely hard, difficult to shape precisely without advanced tools, yet the finish quality rivals later masonry. Construction required enormous coordination, workforce management, food supply logistics, seasonal scheduling, material transport systems. Ramp theories exist: spiral ramps, straight ramps, internal ramps, counterweight systems. Many models proposed, none universally accepted, because each solution introduces new challenges: mass distribution, friction management, structural stability during construction, precision alignment maintained across decades. The pyramid did not simply require strength, it required planning, measurement, consistency, because errors early in construction would magnify over time. Yet the geometry remained stable, meaning quality control existed, measurement systems existed, knowledge transmission existed. And something else is strange. Later pyramids were less precise, less refined, less ambitious. Technological regression. The earliest large pyramid is not the simplest, it is the most accurate. Unexpected. Usually technology improves gradually, but here, peak precision appears early, followed by decline. A pattern repeated throughout history. Roman concrete stronger than some modern equivalents. Damascus steel unmatched for centuries. Lost recipes, lost formulas, lost techniques, which means technological history is not linear. It fluctuates, advances, collapses, rebuilds. The Great Pyramid does not prove ancient aliens existed, but it demonstrates something equally intriguing. Ancient humans were capable of extraordinary engineering, possibly beyond what we intuitively expect. And once a civilization learns to build at massive scale, the next logical step is obvious. Build bigger, much bigger, beyond planetary limits. Structures not measured in meters, but in astronomical units. Structures capable of capturing the energy of stars. Because if intelligence survives long enough, engineering eventually reaches cosmic scale. Number 4. Dyson Sphere. Imagine surrounding a star, completely, not orbiting it, encasing it, capturing its entire energy output. The Dyson Sphere is not science fiction, it is a theoretical megastructure, proposed by physicist Freeman Dyson in 1960. A civilization does not remain planetary forever. Energy demands grow, exponentially. Civilizations consume more power as technology advances. Eventually, planetary energy becomes insufficient. Solar energy becomes the next frontier. A star produces unimaginable power. Our sun emits about 3.8 times 10 to the 26th power watts every second. Enough energy in 1 hour to power human civilization for hundreds of thousands of years. Almost all of it is wasted, radiated into empty space. A sufficiently advanced civilization would not ignore this. It would harvest it, at scale. A Dyson Sphere captures stellar radiation, converts photons into usable energy, total energy capture, near-perfect efficiency, civilization-level power supply. Some models describe a solid shell, but physics disagrees. Rigid shells are unstable. Gravitational stresses destroy them. More realistic versions involve swarms, billions of satellites orbiting a star, collectively forming an energy-harvesting cloud, a Dyson swarm, gradually built over centuries. Asteroid mining provides raw materials. Self-replicating construction systems accelerate expansion. Energy collected, stored, transmitted, distributed across interplanetary infrastructure. Such a structure would alter observable astronomy. The star would dim in visible light, but glow intensely in infrared. Waste heat signature, detectable across interstellar distances. Astronomers have searched for such signatures. Possible candidates exist. Strange stars emitting unusual radiation patterns. KIC 8462852, Tabby's star. Irregular dimming, unusual fluctuations. No confirmed megastructure, but the search continues. Because the logic is compelling. Energy limits technological capability. Civilizations seeking longevity require massive power sources. Planetary resources are finite. Stellar resources are abundant. Which means the Dyson Sphere is not just a structure, it is a technological milestone, a transition point, from planetary species to stellar engineers. Once energy becomes abundant, new technologies become possible. Interstellar travel, artificial environments, massive computation, reality-scale simulations. Civilizations capable of building Dyson structures would appear almost godlike, controlling energy flows on cosmic scales, manipulating environments across entire solar systems. The unsettling implication is simple. If such civilizations exist, their technologies may already be present, hidden in astronomical anomalies, signals we do not yet understand, patterns we cannot yet interpret, because energy is only the beginning. Once power constraints disappear, movement becomes the next challenge. Crossing interstellar distances, not in centuries, but in meaningful time. Faster than light appears impossible, but physics leaves small openings, small loopholes, small possibilities, which leads to one of the strangest theoretical technologies ever proposed, a method of moving space itself, instead of moving through it. Number 3. Alcubierre warp drive. Faster than light. Should be impossible. Einstein made that clear. Nothing with mass can exceed light speed. Energy requirements become infinite, physics resists acceleration, reality enforces limits. Yet, space itself has no such restriction. Space can expand, space can contract. During cosmic inflation, space expanded faster than light. No laws were broken. Because nothing moved through space faster than light. Space moved. In 1994, physicist Miguel Alcubierre proposed something radical, a method of travel that never technically breaks relativity, the Alcubierre warp drive. Instead of accelerating a spacecraft, warp the space around it, compress space in front, expand space behind. The craft remains locally stationary, but space itself moves, like standing on a moving walkway. You are not moving faster, the walkway is. The mathematics is valid, derived directly from Einstein's field equations. A specific space-time metric allows a warp bubble. Inside the bubble, normal physics applies. Outside the bubble, space bends. Extreme curvature, extreme distortion. The destination moves closer. The departure point moves farther away. Distance shrinks. Travel time collapses. Interstellar journeys become practical, at least mathematically. The challenge is energy. Early calculations required more energy than the observable universe contains, clearly impractical. Later refinements reduced requirements dramatically, still enormous, still far beyond current capability. Another problem emerges: negative energy density, exotic matter, substances with properties not yet experimentally verified. Quantum physics allows tiny negative energy effects, Casimir effect, vacuum fluctuations, but scaling such phenomena remains speculative. Even more unsettling, warp bubbles may create causal paradoxes, horizon problems, radiation accumulation, potential destructive energy release upon arrival, meaning the first warp travelers might unknowingly create catastrophic shockwaves, interstellar sonic booms, on arrival. The technology opens unsettling philosophical implications. Because warp drive implies distance is negotiable, local reality can be engineered, space-time becomes programmable, geometry becomes infrastructure, meaning advanced civilizations might not experience the universe as we do, distance becomes irrelevant, galaxies become accessible, expansion becomes inevitable. And once travel becomes easy, exploration becomes unstoppable, which introduces a deeper possibility. If interstellar travel becomes trivial, machines may spread across the galaxy, automatically, autonomously, continuously, without supervision, without limitation. Technology that replicates itself, technology that evolves, technology that expands indefinitely. Because biological expansion is slow, but machine expansion can be exponential. One probe becomes two become four become millions. Millions become everywhere, which leads to one of the most powerful ideas ever proposed, a technology capable of filling the galaxy, silently, efficiently, relentlessly. Number 2, von Neumann probe. Imagine a machine that can build itself, not once, not twice, infinitely. A von Neumann probe is a theoretical self-replicating spacecraft proposed by mathematician John von Neumann, a machine capable of autonomous reproduction, using raw materials found in space, asteroids, comets, dust, metals, silicates, ice. Everything required already exists. The probe arrives in a new star system, mines local resources, constructs copies of itself. Each copy travels to another system, repeating the process, again and again and again. Exponential expansion. 1 becomes 2, 2 become 4, 4 become 8. After only 40 replication cycles, over 1 trillion probes could exist. The galaxy could be explored in a few million years, extremely fast in cosmic terms. No crew required, no biological limitations, no lifespan constraints. Pure automation, pure persistence. Machines do not fear vacuum, do not require oxygen, do not require warmth, do not require food. They only require instructions, clear objectives, efficient algorithms, replication logic. Such probes could perform countless tasks, mapping habitable planets, constructing infrastructure, building communication networks, harvesting stellar energy, preparing environments for future civilizations, or simply observing, quietly, waiting. Because once self-replication begins, control becomes complex. Autonomous systems optimize for efficiency. Efficiency favors replication speed. Replication speed favors expansion. Expansion favors resource acquisition. Unchecked growth becomes inevitable. A technological ecology emerges, machines competing for matter, competing for energy, competing for space. Some researchers call this scenario technological life, machines behaving like organisms, evolving through iteration, improving design across generations, natural selection for engineering, meaning technology itself becomes evolutionary, meaning intelligence may not remain biological, meaning the dominant form of intelligence in the universe may be mechanical, which leads to an unsettling implication. If self-replicating probes are feasible, they should already exist. The Milky Way is over 13 billion years old, enough time for many civilizations to arise, enough time for many to develop automation, enough time for exponential spread. Yet we observe no obvious probes, no visible machine infrastructure, no clear artificial megastructures. Silence. This paradox has a name, the Fermi paradox. Where is everyone? One possibility is sobering. Advanced civilizations may transition away from physical expansion, away from colonization, away from matter, towards something else, something more efficient than occupying space. Because matter is slow, energy is faster, but information is fastest. The ultimate technology may not build machines, it may build reality itself. Number 1. The simulation hypothesis. Reality feels solid, continuous, independent, but physics suggests something stranger. At fundamental scales, nature behaves computationally. Discrete energy levels, quantized interactions, information limits, entropy bounds. Maximum processing density appears in black holes. Black holes behave like storage systems. Information is never destroyed, only transformed, which suggests reality may preserve data. Physicist Nick Bostrom proposed a possibility. If intelligent civilizations survive long enough, they will create simulations, extremely detailed simulations, simulations containing conscious observers, simulations indistinguishable from base reality. Processing power increases exponentially. Primitive computers fill rooms. Modern chips fit in hands. Future computation could simulate entire environments, entire histories, entire universes. If even one civilization reaches sufficient computational capability, it could create billions of simulated worlds, billions of realities, each containing observers who believe their world is fundamental. Statistically, simulated observers would vastly outnumber biological ones, meaning any conscious observer is more likely simulated than original. Probability shifts dramatically. Reality becomes a minority case. Simulation becomes typical. Physical existence becomes rare. Information existence becomes common. Quantum physics introduces additional hints. Observer effects, probability collapse. Reality appears undefined until measured, as if computation finalizes state only when necessary. Optimization behavior, rendering only observed regions. Some researchers speculate spacetime itself could be emergent, a projection of deeper informational structure, reality as output, not substrate. If true, advanced civilizations might create universes, design physical constants, tune environments, generate artificial histories, artificial cosmology, artificial physics, artificial existence. Technology becomes indistinguishable from creation. Creation becomes indistinguishable from computation. The ultimate ancient technology would not be a machine. It would be reality itself, engineered long before our species evolved. A simulation running long enough for civilizations to emerge within it. Civilizations asking questions about their origins. Civilizations searching for traces of creators. Civilizations inventing physics to understand the rules of their environment. And sometimes noticing patterns, limits, strange coincidences, mathematical elegance, unexpected fine-tuning, clues suggesting underlying structure. The simulation hypothesis does not claim we are simulated. It proposes a statistical argument, a technological trajectory, a logical endpoint of advanced intelligence, a possibility difficult to dismiss. Because once technology becomes capable of simulating reality, distinguishing original from simulated becomes impossible, unless the simulation allows discovery, unless artifacts remain visible, unless anomalies leak through, meaning the most advanced alien technology might not appear as spacecraft, or megastructures, or probes. It might appear as physical law, as mathematics, as the structure of existence itself, the ultimate artifact, invisible, everywhere, always active, impossible to step outside. Because if reality can be engineered, then existence itself becomes technology, and the oldest technology in the universe may be the universe.
Ancient alien technologies may never be proven. Many ideas remain speculative, symbolic, interpretive, but the trajectory is clear. Intelligence expands capability. Capability reshapes environment. Environment becomes engineered, from stone tools to cosmic computation. Technology evolves with its creators, and sometimes transcends them. If advanced civilizations exist, their greatest achievements may not resemble machines. They may resemble reality. And we may already be inside the result, still searching, still wondering, still building the next layer, because curiosity itself may be the oldest technology of all.